Hello, my name is Cody Reif. To the students I would say, hello, my name is Mr. Reif. Today we're working in a laboratory that deals with cell size. What I would generally have is a big screen, a whiteboard, obviously the classroom with students, and would be on the board it would be a daily 5 where the students would take the first 5 minutes of class. They'd fill out two questions. First one would be explain why cells get bigger in time, or why do cells divide? And then the second one is explain the relationship between genes, DNA, and a chromosome. So what I would do is I would choose a student for each question to answer. If they don't know, they can ask a partner nearby to help them out. We would talk as a class, discuss it, and in other words, cells divide so that we have life. We all start as a zygote, one cell, we divide, and then obviously over time we grow because we have more cells in our body. The second question we were talking about genes. Genes are the blueprints or the map for growth, and they are found within DNA, which are bound up around histones on a chromosome. Briefly touch on all of that, talk a little bit about mitosis, meiosis, and how sexual reproduction works, but predominantly we want to talk about cells. We have 4 cells here, small one to the big one. I would ask the students, okay, think about themselves sitting in the seat right now compared to when they were a baby. When they were a baby, were their cells this big? And are their cells this big now at the age they're at in 9th grade? Well, the answer is that they're all the small cells. Cells get to a certain size, they divide due to waste limitations, nutrient uptake limitations, and others, which we'll get into. But for today, we're going to construct these cells. We're going to calculate the surface area, the volume, and the weight for each size cell. We're going to talk about efficiency, waste removal, nutrient uptake, all that related to these. So first, what I would do is I would have students think, why do cells divide? That is the big question for today. Then I would hand out all the students, so these would already be on the lab benches. They would get a sheet that looks similar to this, and it has 4 diagrams on it. One for the 1x1 cell, a 2x2, a 3x3, and a 4x4 cell. What I would do is we need to go over the equipment first. They would take manila folders, cut them in half. That makes a sturdier cell. I'd give them a sheet of graph paper, sand. We're going to use sugar. And then for accommodations and modifications, I would already have it drawn out for them where the students, all they have to do is cut them out. So then you need tape, scissors, and a ruler, and the data sheets, but we'll get to that. So all they need to do is count for the 4x4. It's 4x4 for one face, but we need to make a big one, so it's 12, 4, 8, and 12 across. So I'd instruct them, take your ruler on the metric side, which is all the small numbers, find the 12, take your sheet, measure out 12 centimeters, mark it with your pencil. On that same line, mark 4 centimeters and 8 centimeters. Then on the other side, do the same. Do it all the way around until you get a sheet like this. And then they would cut it out. Make sure they leave these little flaps so that we can tape it together to give us a figure like this. The little one's the hardest just because it takes a little more time because of the small pieces of tape. But we're going to do it for a 4x4, 3x3, 2x2, and a 1x1. Then what we'll do is we will move into weighing the cells. But first we need to go over the data sheet. Column 1 is cell size. 1, 2, 3, 4. Just how it suggests. Smallest is the little, 1 is the smallest, 4 is the biggest. Second column is the area of one face. So you're taking base times height, and then you're multiplying them. So 1 times 1 is 1, 2 times 2, 4, so on and so forth. You'd fill out that column. Then we'd go to the third column, which we would take the area of a face, multiply that by 6, because there's 6 sides. Yes, there's not one on the top, but that's so we can fill it with sand. So that would give us our surface area for the entire cell, which would relate to the nuclear membrane, or the outside of the cell. Then we would calculate the volume for all four. You would take the cell size, the first column, and cube it. 2 times 2 is 4, times 2 is 8, so that would be 8 centimeters cubed, and so on and so forth for the other three. Then we would take the distance, so we would take the cell unit size, which would be 2, divide it by 2, which would give us 1. So then that would be the distance, be 1 centimeter from the edge to the center of the cube, or the cell. And then we're going to weigh them. So what we'll do then is we will take our sugar or sand, dump it in our cubes carefully, take it all the way to the rim, then we would set it on the scale. We got to put that down. And then we would weigh it. I'd instruct them, start with everything to the right, use the big one first, and then if it's too far, and use the second biggest, and then you decrease until it teeters. Then use the small one to get your smaller digits. We would record that in grams in the far right, it should be over here, in grams. Once this entire table is filled out, we can, as a group at our tables, fill the second chart out. Cell unit size, then you have total surface area to volume ratio. So you'll take column 3 over column 4, and you should reduce that down to about 1, and it's possible. For the third column, you'll take the total surface area to weight. This one's going to be difficult because you have to use a decimal point, so do the best you can, and then you're going to graph them. I'll come around and make sure that these are correct, and that these are filled out. Underneath the graph, it says to make a graph. There's going to be 4 graphs, so I take the graph paper, fold it in half, and then I would make this one. Everything on the x-axis is cell unit size. The y-axis for the first one is going to be total surface area. And you take colored pencils and you would graph it, color it in, see a trend. Then we'll go to the next page. It would be cell unit size to total volume. You'll see a trend there. You have to record your data, color it in, make it look pretty. Then you do the ratios. You'll compare the ratios on the back. Cell unit size is the x-axis. Y-axis is total surface area to volume. On the other one, it would be total surface area to weight. So we'll talk about that once we're finished. Then, at your tables, when the students are in their own seats, they will fill out these questions 1 through 10. And then as a class, before class, we will review everything, understand why the small cell is the most efficient and why the big cell is the least efficient. So other than that, this is where I would ask questions. If anybody has any issues or questions, I would instruct other kids to do certain tasks, and then we would begin the lab. I would walk around, make sure they're doing it correctly, and then we would reconvene in our desks and go over the data sheet.